video, we are going to look at some circuit calculations. In order to do this, you will need all of that knowledge from the previous electricity videos. So it turns out that voltage, current and resistance are all related. And they're related via the following equation. V is equal to I multiplied by R. V, your voltage in volts, is equal to I, your current in amps, multiplied by R, your resistance in ohms. And we're going to use this equation along with all of our circuit rules to work out the missing values in various circuits. Right, no time like the present. We're going to ease in. We're going to start with this circuit. And we want to know what's the resistance of the bulb. So let's write down the information that we have. V is equal to 6 and I is equal to 2. Okay, and we've got that equation, V equals I times R. Therefore, my R is V divided by I. 6 divided by 2 is equal to 3 ohms. Easy. Okay, let's ramp up the fun. And in this circuit, we're trying to find the different voltages. So for each bulb, we're going to write down the information that we have. Bulb 1, we have a current of 3 and a resistance of 2. And bulb 2, because we're in a series circuit, we also have a current of 3 and it's given us a resistance of 1 ohm. Okay, let's find the voltage for bulb 1 using V equals I times R. So V is equal to 3 times 2 is 6. Okay, and for bulb 2, we'll work out the voltage. So again, V equals I times R. So V is equal to 3 times 1 is 3. Final missing voltage is the supply voltage. And this is where I've got to remember my circuit rules. In series, the supply is equal to the sum of the voltages across my components. So the supply voltage is equal to 6 plus 3 is 9. Okay, let's not neglect the parallel circuits. Have a look at this circuit here. This time we want to find the resistance of each bulb. So what information do I have for the bulb on that top branch? Well, the current is 3. And because this is a parallel circuit, I know that the voltage of the supply gets applied across each branch. So that bulb must have a voltage of 6 volts across it. And in the bottom branch, I have a current of 2 amps. And again, I have a voltage of 6 volts across that bulb. Okay, so let's find the resistances. In branch number 1, I have my voltage 6 divided by my current 3 gives me a resistance of 2. And in my bottom branch, I have a voltage 6 divided by my current 2 gives me my resistance 3 ohms. Right, time for the mega circuit. We're going to find the resistance of those 3 bulbs. First, we're going to see if there are any hidden values that we can get out of our circuit by just using our circuit rules. In parallel, my current into a junction equals my current out of a junction. So that 5 amps coming in is equal to 2 plus, well, it must be 3 on the other branch going out. Whilst I'm in this branch, I can also write the voltage over that bulb because my voltage in parallel across each branch is the same as the supply. So if the supply is 10 volts, then the voltage across that bulb is also 10 volts. And in my bottom branch, the voltage again across the entire branch should be 10. And since that bulb there has a voltage of 6 across it, then that must mean that this bulb has a voltage of 4 across it. Okay, now we can work out the resistances. Let's do the top bulb. Resistance is voltage over current. So that is equal to 10 divided by 3 is 3.3 recurring ohms. Okay, and the first bulb in our bottom branch, that is the voltage 4 divided by the current 2 is equal to 2 ohms. And the next bulb is my voltage 6 divided by my current 2 is equal to 3 ohms. Okay, hope you found that helpful. Please do download the notes and check out the next video for IV curves.